What's gaming gamers? It's your boy Olino, and I'm coming at you with something a little different from what I usually do. I figured we'd do math, something really, really fun. More specifically, though, I wanted to show you a neat way. I remember in school being asked, not even doing that right. How do you count every number? It would be easier to just type this. How to sum every number, every integer rather, from 1 to 100. So this would be inclusive, so 1 to 100. So you're basically doing 1 plus 2 plus 3 plus dot 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 all the way up to 98, 99, 100. And there's a really easy trick to this. You might have seen it before, but maybe not. And basically, that is the way I think of this. You can imagine, so we can ignore 100 for the time being. 100 is 100. But if we think about it, we have 1 and we have 99. And these two sum up 100. And then if we take 2 and 98, these also sum up to 100. And hopefully you're starting to see the pattern here. We can keep doing this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can all map those to, going backwards, 10 maps to 90, 9 maps to 91, so on and so forth. So then we can think about, okay, so how many pairs of those numbers do we have that add up to 100? Well, we know that going from 1 to 49, we're going to have a match from 1 to 49. We're going to have a number that matches each of those numbers from 51 to 99. So 1 to 40, basically we'll have 1 to 49, we'll have 98 total numbers where each pair of those numbers sums to 100. So that means we have 49 pairs that sum to 100. So we can take 49 times 100, and we get 4,900. And then we still have a couple numbers left. We still have 50, because remember, there's only 150 from 1 to 100. And then we still have our original 100. So then you have to go in, add 150 to 4,900, and you end up with 5,050. And so this is really cool for 100. And then you can also extend this if you ever need to sum numbers. It's a little trickier, but you can do this for summing numbers. Say you want to sum from, say, 1 to, 40, for example. We could do a similar trick. We know we're going to have 1 plus 2 plus 3 plus dot, 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 all the way up to 39, 40. And so what we can do is we can take 1 and 39, and we get 40. And then we can take 2 and 38, and we also get 40. And so once again, we know that we'll be able to do this from 1 to 19. So then from 1 to 19, we're basically going to have 19 pairs of integers that sum to 40. So then we're just doing 19 times 40, which, okay, that's a little bit more complicated to actually do. Pull out a calculator for that or whatever. But then that adds up to 760. And then again, we still don't have 20. And we're still missing our original 40. So we add those up. And we end up with 820. So that's a quick little trick. If you need to sum every integer, again, an integer refers to a whole number. So things like 1, -1, 3, 7, 8, any of those are integers. So they're just whole numbers. They have no fractions associated with them. But yeah, this is just a neat little math trick. I remember in school doing this. I think it's famous. There's a famous story of like von Neumann or somebody who was asked this question in grade school, and he was able to answer it immediately. And this is just sort of a trick you can do to find out, and then you can answer questions like this really easily, and you don't have to, plug each individual number into a calculator. You can turn a series of addition problems into just a multiplication problem with a little bit extra addition. But yeah, that's it. Hope you guys liked the video.